For these examples, we're going to follow the displacement of a boat. Let's say the boat moves 50 meters to the right in the x direction, and then it moves 20 meters up in the y direction. During the first part, this is the boat's displacement vector, which we'll call d1 for displacement 1. It has a magnitude of 50 meters. The second displacement vector, d2, has a magnitude of 20 meters. What is the boat's total displacement, specifically the magnitude and direction? The boat traveled these two displacements, but we want to find the vector that tells us the total displacement between the start position and the end position. This vector, d total, is the sum of the d1 vector plus the d2 vector. This is what we call the resultant vector when we add d1 plus d2. So how do we find the magnitude and the angle of d total? We learned in a previous video that if we want to find the magnitude and angle of a vector, we need to know its x and y components. So how can we find the components of d total? First, we need to find the x and y components of d1 and d2. Second, we add the x components to get the total x component, and we add the y components to get the total y component. Third, we use the total x and y components to find the magnitude and angle of the total displacement vector. Let's walk through each step. First, let's find the components of d1 and d2. d1 is pointing directly in the positive x direction, so delta x1, the x component, would be 50 meters, the same as the vector itself. d1 doesn't have a y component because it's parallel to the x-axis, so delta y1 would be 0. d2 is pointing in the y direction, so delta y2, the y component of d2, is 20 meters. d2 doesn't have an x component because it's parallel to the y-axis, so delta x2 is 0. Now, let's find the x and y components of d total. Delta x total would be delta x1 plus delta x2. Delta x1 is 50 meters and delta x2 is 0. So delta x total is just 50 meters. We do the same for the y components. Delta y1 is 0 and delta y2 is 20 meters. So delta y total is 20 meters. This is the simplest example of adding two vectors because each vector is one-dimensional. We might have been able to see that the x component of d total is 50 meters and the y component is 20 meters. But it's worth walking through the steps, and we'll do a more complicated example next. So now that we have the components of the total displacement vector, we can find the magnitude and the angle. Remember, the components and the vector form a right triangle, so we can use geometry and the trig functions to find what we're looking for. For the magnitude, we use the Pythagorean theorem. We're not going to write the total subscript to keep things easier to read. We plug in 50 for delta x and 20 for delta y, and we find that the magnitude is 53.85 meters. For the angle, we use the inverse tangent function. If we want to find this angle, then we plug in 20 for delta y, which is the opposite side, and 50 for delta x, which is the adjacent side. That gives us 21.8 degrees for this angle. So the boat traveled along displacement 1 and displacement 2, and its total displacement was 53.85 meters at an angle of 21.8 degrees. 53.85 meters is the straight line distance between the start point and the end point. So that's how we add one-dimensional vectors to find a total vector or a resultant vector.